Hello, everyone. Welcome to this session. For today, we are going to learn about trees. And last time, in our previous discussion, we talked about or we learned different or a few of linear data structures, particularly stack and queue algorithms and linked list. So we even tried implemented the stack and queue in an array-based implementation, and then we have also tried the dynamic-based implementation. Though we haven't really implemented stack and queue into like using a linked list dynamic-based data structuring, but you can actually implement stack and queue in using linked list. Okay, you can try that one out. So basically, these linear data structures are used to arrange data in a particular order or in a particular manner. The problem with these linear data structures is that it has, in terms of traversal, especially specifically linked list, when you're going to look for a certain value, you will have to traverse from the beginning up to the end. So if a value is not found, and then you have actually visited all the nodes, okay, because you have to traverse from the beginning towards the end. So that's it. That's basically the problem of linked list data structure that makes it um, slow, no, in terms of searching. Okay, so this time in we have here a non-hierarchical, non-linear data structure or hierarchical data structure, which is called a tree. In computer science, there are various data structures that are actually going to help us arrange our data in different forms. Among them are actually trees. So trees are widely used abstract data structures that simulate a hierarchical tree structure. So it is a tree is actually an inverted tree where the root is at the top most portion, and all the leaves and its branches are at the bottom part. So a tree normally or usually has a root value and subtrees that are formed by child nodes, and it has also its parent node. There is this relationship between child, parent, and a child, and a child and a parent. So trees are, as I've said, nonlinear data structures. So this time we will talk about general tree. So what is general tree? General tree is a kind of a tree which has no limitation on the number of child nodes in it can hold. So it can actually it can have as much as nodes or as much as children as it can. So now let's get to dive in a few terminologies of a tree. But before that, let's have this here. So there are two figures here at the bottom part. So we have here on the left side is can be considered as a tree, particularly a general tree. So because each node has more than two children, and let's say for an instance, the A has children B and C, while B has children D, E, and F. So it has three children actually, and this is considered as a tree. Okay, and specifically a general tree. While on the right side, you have here, it forms like a tree, no? But it's actually not because the node B is actually has an edge going to the other branch, which is uh, leaf E. Okay, so later on you will learn the different terminologies that I am actually talking about. So we have B is going indirectly to E. So therefore, it's not a tree. Okay. So now let's have here a general tree. So um, which forms actually a tree, no, an inverted tree. So let's have a few terminologies of a let's get started. Okay. So first term that we are going to discuss is a root. So what is a root? Okay, a root is the topmost node of the tree. it is actually a node without a parent. So definitely this 22 is our root. So the topmost node or the topmost node of the tree, it doesn't have any parent. So because it is the parent. Now, let's talk about the edge. What is edge? An edge is the link between two nodes. So this is root is considered as a node. This one is considered as a node. This one is considered as a node. Well, this one is also considered as a node. Therefore, and the link between the these nodes are actually what we call. So this one is an edge. Okay, so the connection between two nodes. This one is an edge of root node 22 going to its child 10. This one is an edge here. This one is an edge going to its child, an edge going to its child, another an edge going to its child, and also edges going to its children. Okay, so now let's talk about parent. Okay, we already determined that 22 is a root and it's considered as a parent. Okay, so but when we talk about parent, it is actually a node that has an edge to a child node. So basically, we can consider 2 as a parent, okay, and it is a root, okay, and it has two children, 18 in the left subtree, and then 26 in the right subtree, and then also it has a child, which is at the center, no? So 18, 10, and 26 are actually the children of 20. So you have the parent and the okay. So children or child is a node that has a parent node. So again, these are the children of 18, children of 26, children of or children of 26, both 25 and 29. So parents are 18, 10, and 26. So let's say parents, okay, the parent sets are we have here uh, 18, have here also 10, and then 26. Okay. Then you have here the children or child. So let's say child of um, 18. So the child of 18 are okay, 16, 15, 15, and 9. Okay. So that's child. So all right. So we have also this what we call left child and right child. So basically, left child are those nodes that are uh, found in the left subtree of subtree or a binary tree, or as a tree rather. So this is the left child, this is the right child. Okay, so in general tree, you have also here a children, which is at the center. But in this is actually, I mean, later on we are going to talk about binary tree. In binary tree, there are only at most two children. So meaning it cannot have more than two children. So we have here left child also of 18, which is 16, and we have here 19, and then 15 is child of 18. Okay, now let's talk about path. So what is path? A path is a sequence of nodes connected with edges in which there is no repetition of. So traversing one node down, this is actually traversing one node to its children. So let's say for an instance, we are going to traverse uh, node 16, a path. So going to 22 and then 10. So traversing 16 to 18 to 22 and to 10 is actually a path. Okay. So if I say 16, 18, 16, 18, and then let's say 25, 16, 16, 18, and then add to siya 25, it's not a path. No? It's non-path or not a path. Okay, so that's a path. So there is also this what we call path length. So path length is the number of edges connecting the sequence of path. So the path length is, so we have here one, one, two, three. So the path length of this one is actually is a path na no. Path length of this one, okay, is equal to, okay, so that's it. That's how you do a path. So you have here 16. How about 16, 18, 22? So we have one edge. We have here one, two, three, four, going to 28, 5. So we have a path of 5. So if a path exists between two nodes, one is an ancestor and the other is descendant. So when we talk about ancestor and descendant, ancestor, descendant, son, bitaw. So ancestors are like are like parents or grandparents. Then descendants, of course, are your children or yeah. So ancestors and descendant. So let's say for an instance, you have here 18. What are the descendants of 18? So you have the 16, 15, and 18. So descendants of, okay, descendants of, let's say, descendants of 18 are 16, 15, and 9. Okay. So how about ancestor of 16? So when we talk about ancestor of 16, it should be 18 and 22. Okay. So these are the ancestors of 16. So yan. Okay. Now, how about this ones? 16, 15, and 19 are called siblings. So, igsuon, no? Because they are connected to the same parent. So, 16, 15, and 19 are also considered as lives or live. Okay? So what are lives? Lives are nodes having no children. Okay? A lives a nodes with no child or children. Since 16, 15, and 19 are yeah siblings which has siblings that has no children, so therefore we can consider that this are them as lives. Okay, so about 18, 10, and 26. So 18, 10, and 26 are siblings. Okay, and then 18 is not considered as a live. Okay, and also 26 is not considered as a live. So only 10 is considered as a, all right. What else? So we have 25 as this is a live, 28 and 33 are also. So other term for lives are external no. Okay. Now let's talk about the by the way, when you talk about parent or this one, 18, 26, these are actually called as internal node. So internal nodes are parents. These are basically parents. These are parents that has children and except for a root or a parent, except for a root. So basically, based on this tree, the internal nodes are 18, 26, and 29. Or they are also called as terminal node in other books, I guess. So 18, 26, and 29 are internal nodes. So these are parent nodes. Okay, why 22 is not considered as a terminal nodes or internal nodes? Because it is a root. Okay, so it's a parent, but it's a root. It's a special node. Okay, it's the starting point of all the nodes where we are going to start traversing. No, so where do we start to traverse? Okay, so mo ni ato ang basis for traversal. Okay, so the root or the parent node. Okay, and how about height? So there is also what we call height. So height is the length of the longest path to a leaf. The height of a tree is the maximum depth. So what is depth? We have also another term. So we have a depth. So depth naman is height is depth plus 1, depth plus 1, and then the depth is the length of the path to its root. No? The depth is the length of the path to its root. So this is depth. Okay, by the way, sa trees, na ay instances na or other books na ang gamit nila is they start with depth 1, okay, then napoy uban uses depth 0. So let's say we are going to use this as this is depth 1. Okay, so this is depth 0. So therefore this is depth 1, and this is depth 2, and this is depth. So therefore the depth of this tree is 3. Okay. Then, so since the formula of the height is depth plus 1, therefore the height of this tree is okay. So we also have level. So sometimes ang level is also uh, 0 ang start. So we have level 0, level 1, level 2, level 3. So this is first level. Okay, so this is level 0. This is level 1. All of this, no? So level 1 is siya. And then kani sila din na part, level 2. You have here the last level, which is our level here is, if you start with 0, therefore our level is 3. Okay? So it depends sa imuha, no? So again, I other books na start sa 1. This is level 1, level 2, level 4. If that's the case, the level is 4 for this 3. Okay, subtrees. So these ones are the left subtrees, while this one naman are your right subtrees. Now, what is a degree of a node? So degree of when we talk about degree of a node, this is the number of direct children of the given nodes. So let's say the degree of 18 and 22 are 3. Okay? So the degree of 18 and 22 are 3, or the degree is 3. Oh, yeah. So the degree of 18 is 3, the degree of 22 is 3 because it has three direct number of children. Okay? So, how about if you have the collection of trees, so you have, let's say for an instance, you have another tree here, okay, you have also another tree here. So, and this is all collection of trees because like in our file system, we have local disk C, it's actually considered as a tree. Then local disk D is considered as another tree. Local disk F is considered as a tree also because inside of it there are containing folders and file systems, and inside of a folder we have another subfolders. So we can consider it as each of that as a tree. Then we call this as we call that as forest. Forest is a collection or bunch of, okay? So bunch of, so I guess these are the basic terminologies of trees, and thank you guys for watching this video, and don't forget to subscribe. Without, thank you guys. Have a great day. Bye bye.